Hi, AP Stats students. Can you hear my husband humming in the background? He just stopped. Anyway, today is video number 2. What is the question asking? So I'm just going through released exams and talking about, I want to try to make these videos like 10 to 12 minutes talking about what's the question asking and what would you do. I'm not going to do the problem with you. I'll just talk about how would you execute this problem. We've gone through everything that you need to know for the AP exam. And now there's our chance to do this. I will be doing this as well, but I'll be going through it a little bit more thoroughly, not video 2. I'll have a review video 2 that I'll be going through with students live in a Google Meet as well. So check those out as well. Those are on Schoology. All these videos will be on YouTube as well. So this one is talking about a company bakes computer chips in 2 ovens. Ovens A and B, the chips are randomly assigned, blah, blah, blah. Now, here's the thing. It says the percentage of defective chips coming from these ovens for each hour of production throughout a day is shown below. Okay, percentage typically would make you think, oh, we have a Z involved. However, keep reading. The percentage of defective chips produced each hour by oven A has a mean. We're dealing with a T. And a standard deviation of 5.20. That's a T. The percentage of defective chips produced each hour by oven B has a mean of 32.44 and a standard deviation of 3.78. The hourly differences in percentages for oven A minus oven B have a mean of 1.11 and a standard deviation of 4.28. Does there appear to be a difference between oven A and oven B with respect to the mean percentages of defective chips produced? Do not say yes. I talked about that in other videos. I once had a student who came and told me they wrote yes as an answer. Here it says, give appropriate statistical evidence. When the question is asking about or stating to you, give appropriate statistical evidence, that means you are doing a test. Now you have to decide what test to do. I am hoping that you are practicing that applet that I posted for you guys. So you're going to get a bunch of them at you at once. But here's my attempt to kind of give you some explanation behind some that have come from the College Board. So some people may want to say it's a 2-sample t-test for mu1 minus mu2. Here's the catch. When you look at this, you see the hour. Okay? And what that means, you guys, is these ovens and the chips being baked were matched up by hour. Okay, so that means what we have is we have a 1-sample t-test for matched pairs because they're matched up by the hour. Wait, sorry, I had to pause it for a second. So if I repeat something, forgive me. So what we just talked about is we know that we're going to do a test. Why? Because it says give appropriate statistical evidence. It does not say construct an interval, okay? Next, it's talking about a difference. I told you, noticing that, hey, this data is paired by the hour, which means it's a matched pairs test, okay? Now, here's the catch. I actually just paused it to double check the rubric because I was pretty certain when I read the rubric that they actually give you credit if you do a 2-sample t-test for mu1 minus mu2 as well. So if you're panicking a little bit and you're like, wait, what? It's a matched pairs? Don't panic too much. In this rubric, they gave credit for that as well, okay? I think, in my opinion at least, the indication that it should be matched pairs is because of this hour right here. If it didn't have the hour there with the data attached to the hour, then it would be that 2-sample t-test, in my opinion. But just remember, you get credit if you would have done that as well. So what should we have learned here? Does there appear to be a difference? Do not answer yes or no. Keep reading. Give appropriate statistical evidence. That means you're performing a test. How do I know what type of test? A T or a Z? It's a T because it's talking about means. Next, we should notice the data is paired with the hour, which means it is a matched pairs test. Okay. All right, you guys. Next, let's move on. Hopefully we learned something from this slide. That's the goal. Each question, we just want to learn something, okay? What are we noticing? What's the question asking? Okay, next slide. A random sample of 450 potential voters was interviewed 3 weeks before let me move the video here, sorry guys, before the start of a statewide campaign for governor. 223 of the 415 said they favored a new candidate over the incumbent. Hopefully right away in your head, you are thinking, this is a proportion. This is categorical data. Okay. However, the new candidate made several unfortunate remarks 1 week before the election. Subsequently, a new random sample of 630 potential voters showed that 317 voters favored the new candidate. Okay, what do we have here, you guys? We have 2 samples. That's important to note as we're reading. Do the data support the conclusion that there was a decrease in voter support for the new candidate after the unfortunate remarks were made? Give appropriate statistical evidence. This is a test, a state, a plan, a do, a conclude. Okay? State, plan, do, conclude. Now, how do I know what type of test? Right away, we are noticing there are 2 samples. A sample of 415 and a sample of 630. Next, you guys, we are realizing this is categorical data. It is a proportion. It's telling us part of a total sample. You do not see the word mean in here. So you know you're dealing with a Z. You are not doing an interval, okay? Why not? Because it doesn't say construct an interval. So we have a 2 sample t-test for P1 minus P2. All right, if you have any other questions about this problem or you want me to do a separate video just going through it, just let me know. I'd be happy to do that for you. What should we have learned here? Do the data support the conclusion? Give appropriate statistical evidence. That's a test, okay? We have 2 samples, we noticed there. They are proportions. There's part of the total sample, part of the total sample. So those would be your P hats in the problem, okay? And then it's categorical data, which also supports that Z. You do not see the word mean. Sorry, my kids are opening the doors, so I'm getting a little distracted. Forgive me. Okay, let's keep cruising. Again, the goal today is just to look at 3 or 4 problems and talk about what is the question asking. Okay, so you can hear my husband talking to them now. Okay, each player stood 22 feet from a basket at the same location on a basketball court. Each player was then instructed to attempt to make the basket until 2 consecutive baskets were made. The players who received visualization training were instructed to use visualization techniques before attempting to make the basket. The total number of attempts, including the last 2 attempts, were recorded for each player. The total number of attempts for each of the 20 players are summarized in the following box plots. Okay, I really like this problem. I could foresee a problem somewhat like it because I could see them as saying, hey, compare, right? That would get that socks on. That might be part A. Then part B might be this question right here. Again, I am just thinking about what might happen. And I have posted a video that has come from the College Board about top hints, not hits, for statistics during the exam. And it talks about kind of what to expect from the problems this year. What are their thoughts? And this was made by college readers, okay? AP College Board readers, excuse me. So let's get back to this problem. Based on the box plots, did the basketball players who received visualization training tend to need fewer attempts to make 2 consecutive baskets from a distance of 22 feet than players who did not receive the training? Explain your reasoning. Okay, so here's the catch, guys. They give you a box plot for a reason. They want you to talk about either the minimum, quartile 1, the median, quartile 3, the maximum, okay? They are wondering now, based on the box plot, did players who received visualization training need fewer attempts? And it looks like they did. They needed fewer attempts, disregarding this outlier, but overall fewer attempts to make 2 consecutive baskets. Now, what would you state? You need to, I personally would talk about the medians. Okay, so the median for the visualization looks like it's at 1, 2, 3, and 4. Whereas the median for the no visualization is 6, 7, okay? Oh, I can't write. Okay, So what are we saying now? Okay. It does appear based on the box plot that, and now use their context to help you. Basketball players who receive visualization training tend to need fewer attempts to make 2 consecutive baskets from 22 feet than players who did not receive training. Use theirs to help explain. Why? The median for the visualization is 4. Now you have to state what that median means. That means 50% of the players had needed 4 attempts or less than that, okay, to make 2 baskets in a row. Because a median means 50% of the population or the sample or whatever's happening, 50% had that value or lower than it, okay? So 50%, that's 10 of the players, okay? Just say 50% because that's what it means. 50% of the players took 4 attempts or less than that to make 2 baskets in a row, okay? Compared to, or which is less than would be better, which is less than the no visualization group. The median was 7, which means 50% of them, right, needed to take 7 attempts or less than that in order to make 2 baskets in a row. Okay, so the median of the visualization group. Okay, so what should we have learned from this? Let's rewind. What we should have learned is, hey, use context in the question to help you if you're struggling. Rewrite it as a sentence. Why? Use the given information. I personally would talk about the medians. Now, it doesn't mean that you can't talk about, like, quartile 3 would be fine to talk about as well, okay? But what you would state then is you would talk about the median for visualization, that it is less than the median for the no visualization. And what does a median mean? 50% of that population got that score or less than that. So context, answer the question, and make sure you have that interpretation of that median as well. Okay, you guys, let's move on to the next one. State and check the conditions for conducting a 2-sample t-test for the difference of means. When they have you state and check the conditions, now I can't say the same for this year, because this year, if you watch the video that the College Board gave us, is they might just have you do part of the state plan to conclude. And it doesn't necessarily mean, so in the past, like this problem, usually if they just have you check the conditions, it means one of the conditions is wrong. Okay, that doesn't necessarily mean that for this year, but in this case, when we check the conditions, we are going to RIN. So don't forget that. I'll write that down. And you have to RIN twice. Okay, so random samples. I don't know if there's any randomization in there. I'm not going to worry about that right now because there's a big one that should be just kind of glaring at you right now. It was only 20 players. That's our normal condition right there. Okay. 20 is not less than or equal to, I'm sorry, I screwed that up big time. 20 is not greater than or equal to 30, which needs to happen because of that central limit theorem, okay? But don't forget that T distribution is robust, okay? And because it's robust, you can proceed if 20 is not greater than or equal to 30, okay? But what has to happen is the graphs of the data have to be, they can be somewhat skewed, but they can't have any outliers. These are both, I think, pretty skewed. Let's highlight. Remember, on a box plot to see if it's skewed, start at the median. Draw out to the max, even if it is an outlier. And then go the other way to the min. And this purple line, or pinkish line, is a bit longer than this blue line, which means it's skewed to the right, in my opinion, by quite a bit. And the same thing over here. So they are both skewed. But what really seals the deal for us, you guys, is there's an outlier, and we cannot have outliers. Okay, so that's how you would check those conditions. You would say the normal condition 20 is not greater than or equal to 30, and the box plots are both skewed right, and the visualization has an outlier. Okay, you don't need to state anything in this question about it's not okay to proceed. because it doesn't ask us, is it okay to proceed? It literally is just asking us what the conditions are. So do we have random samples for both groups? Can we do 10 times 20 is less than all basketball players? Are the visualization group versus the no visualization groups independent? If you have questions, any more questions, let me know. Now I do want to go through this part C just a little bit. Okay, so it says, because both distributions are skewed, the psychologist conducted a simulation to test for a difference in medians. 1 second, can you guys hear my kids? I'm going to pause. Okay, I'm going to start over. Because both distributions, visualization and no visualization are skewed, the psychologist conducted a simulation to test for a difference in medians rather than means. For each trial of the simulation, the 20 values of the total number of attempts observed in the experiment were combined into one group and then randomly split into two groups of 10. The difference in the medians, V, so visualization, minus non-visualization of the groups was calculated for each trial. The following dot plot shows the difference in the medians for the 100 trials of the simulation. I really felt it was important. I know I'm getting over that 12-minute mark, but I really felt like that was important to talk about the simulation. And I talked about this one in another video as well, because we just don't spend that much time. And I don't know what to expect this year for the year 2020. So I want to make sure that you are exposed to this. We did it first semester, but it doesn't come back a whole lot like some of the other things do. Okay, so here's all our simulated differences for the visualization group minus the non-visualization group, okay? Using the observed difference in the medians and the results of the simulation, estimate the p-value for a test for the difference in medians. Show the work needed to calculate the p-value. I could see this one being a little bit of like, what am I supposed to do? Okay, so what you're going to do is you're going to say, okay, what can I work with here? Using the observed difference in the medians and the results of the simulation, estimate the p-value for the test of the difference in medians. Well, I need a statistic here, okay? Like this is the same as really of our test. So I have my curve, right? I have my center, which would be 0. This is what we assume to be true. Now I need a statistic. I need a difference in medians. Where do I get that statistic? Well, if I go up here, you guys, here I have 2 statistics, right? I have 2 medians, and I can subtract the visualization minus the no visualization here. So again, part of this is just thinking through, okay, what do I have and what do I need? I need to come up with some sort of p-value, which means a probability. I'm not doing a z-score or a t-score because I'm dealing with medians, but I do have a simulation, okay? I have 100 dots here. And I have a statistic, something that happened, okay? 4 minus 7, which gives us -3. That's right here. Okay, now what is a p-value again? A p-value is the probability of getting this statistic or any statistic or more extreme than that. So that's this area right here, you guys. So I want to see how many dots are in this area out of 100. And that's what gives us our p-value. We did this right away. I think it was Q1, okay? But again, it doesn't come back to us that much. This is a tough problem in my opinion, but I think it's a good one just to prepare you. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So my p-value here, you guys, would be 17. Oops, let's go back to a pen. 17 divided by 100. Okay, so let's talk through what should we have learned from this problem again. Oopsie. Not a huge deal, but I wrote it in the wrong spot right there. We need to get a p-value, okay? We know if there's a difference, anytime there's a difference when we're doing a test, we assume that the null hypothesis, there is no difference. We then need a statistic. We need 2 values to subtract, okay? Where do we get these values? They don't give it to us in part C, but we can go up and it's okay, and we can look. So using the observed difference, here's what we actually observed, you guys. Okay. I wish that they would tell us use the plot above because I'm panicked. I'm not panicked, excuse me. I'm worried that some of you are going to be like, what observed difference, and get a little worried about that. Take a deep breath and just look and say, oh, I do have some observation here. How do I know to subtract 4 minus 7? They tell us the V minus no V. And then think, what is a p-value again? The probability of getting a statistic or more extreme than that, given the null is true. Well, we don't have a Z, we don't have a T, but we do have a simulation. So we can take all of these dots divided by how many there are to get that p-value, which is 0.17. Now part D, based on the p-value in part C, is there convincing statistical evidence? You're not going to go through a state plan do conclude because you've never learned a state plan do conclude in this one. In this case, I checked the rubric. All you needed was to talk about this p-value that you got from part C, okay? Because it says based on that. So that kind of helps you know that you don't have to do the whole thing. It's just asking for the conclude there, okay? It's just asking for the conclude. Because if you think about it, we would talk about the medians, but we didn't learn anything like that. But we have learned about a p-value, okay? So our p-value is very high. We do not have an alpha, okay? So we assume that our alpha is 0.05. So what would I say? Is there convincing statistical evidence that the basketball players similar to the ones in the study who receive visualization training need fewer attempts to make 2 consecutive baskets from a distance of 22 feet than those who do not receive such training? Okay. What would we say then? Based off this simulation, do we have evidence? No, we don't. We have no evidence that. Now use what they have, that the basketball, just retype this sentence, right? That the basketball players similar to the ones in the study who receive visualization need fewer attempts to make 2 consecutive baskets from a distance of 22 feet than those who do not receive such training. Why? Because our p-value is greater than alpha. I like this problem to prepare you guys for this year because this year they're going to stretch you a little bit by applying these concepts that you've learned. And like they said, you're not going to be able to just Google what they give you and you'll get an answer because they've gone to a lot of steps to eliminate cheating and and to make sure our academic honesty is withheld. And this is all my opinion, obviously. And I know you guys are wonderful and you're not going to do that anyways, but I'm just trying to help you kind of talk through a problem that might stretch your brain a little bit more. Okay. All right, we are at the 23-minute mark. I think that's good for the day. I had another problem up here, a couple. I can put that in for another day, okay? Not a huge deal. I think this is enough for today. I think what's most important is that you're watching these videos, that you're learning something from it, okay? And then also, again, another thing is that you are watching anything that I post on my updates. And that applet I posted, you guys, that applet of which test is it? Okay, is it an interval? Is it a test? What kind? It was written by a really big guru in the AP Stats world. I think he's a reader too for the College Board. You guys, please, 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 please do that. Okay. You guys have a great day. We're almost there. We're almost at the test. So hang in there. Stay safe, stay healthy.